Hello everyone, today we're going to be talking about mutually exclusive and inclusive, sometimes people call it the inclusive overlapping events, and finding probability of those things. So first, let's talk about mutually exclusive. So mutually exclusive means that two or more events, they cannot occur at the same time. So that means they have no common outcomes. So for example, if I was playing with a deck of cards, the probability of me selecting a king or a queen, I cannot pull a card out that is both a king or a queen. Okay, so those would be mutually exclusive, all right? Or if I selected a random student, boys and girls would be mutually exclusive. I could not pick someone who's both a boy and a girl, and so on. So there's many different examples of that. So here's the formula if events are mutually exclusive. Okay, so if I wanted to find the probability, all we're going to do is we're going to add the probability of each of these things. Okay, so key thing to remember here, whenever you see the word or, this is always going to mean add. I want to add these two things together. Okay, so or is always going to mean add. So whatever the probability of A is, we're going to add it to the probability of B. So here's an example of mutually exclusive events. So it says, using the standard deck of 52 cards, find the probability of getting either a 4 or an ace, okay? So starting with probability of 4, okay, there are 4 4s in this deck of cards. So the probability of that is going to be 4 over 52, okay? The next thing, probability of getting an ace, okay? There are also 4 aces in this deck of cards, okay? So we're gonna have 4 over 52 as well. And or always means adds, we're adding these things together. So there are 8 cards that are either a 4 or an ace. And we're gonna simplify this. I can divide both of these numbers by 4, so that's going to be 2 over 13. Okay, so if I reach into a deck of cards, I have a 2 in 13 chance of either getting a 4 or an ace. When rolling 2 dice, what is the probability of getting a sum of 4 or a sum of 5? Okay, so this time, these are mutually exclusive because I cannot get both a 4 and a 5 at the same time. So first one, 4s, there are, let's see here, 1, 2, 3. There's 3 different ways that I could get 4, and there's 36 possible outcomes. So I've got 3 over 36. Plus, okay, sum of 5, there are 1, 2, 3, 4. There's 4 different ways that I could roll a 5. So I get 4 over 36. If I add those together, we've got 7 over 36. Okay, and that is fully simplified, and we're done there. The other type of events we're going to see are overlapping. Okay, so overlapping are events that have at least one common outcome. Okay, so if there are any common outcomes, we're going to have to subtract the ones that overlap or overlapping. Because whatever is overlapping, we're counting twice. So since we're counting it twice, we have to pull it back out. So if I was randomly selecting a student from Beaufort High School, and I asked you, what's the probability that someone is either a freshman or a female? There are students who are both a freshman and a female, so we're actually going to have to subtract them back out because we're counting them twice. Or if we're looking at a deck of cards, what's the probability that a card is an ace or a club? So there is an ace that is a club, so that card is getting counted twice, so we're going to have to subtract it because it's overlapping. Okay, and the formula for this is going to be probability of A or B is equal to probability of A plus probability of B minus probability of A and B. okay? So using the standard deck of 52 cards, find the probability of getting a king or a club. Okay, so starting with king, okay, there are 4 kings in this deck of cards. So 4 out of 52 cards are king. Okay, so whenever we see the word or right here, that means we're going to add. Okay, and then club. There are 13 clubs in the deck of cards. Okay, so the probability of getting that would be 13 over 52. But there is an overlap. There is a king that is a club. So we are going to have to subtract that because we counted it twice. So minus 1 over 52. Okay, so if I add these together, I've got 4 plus 13 is 17, minus 1 is 16. So that gives me 16 over 52. And that is going to simplify down to 4 over 13 if I divide both of those numbers by 4. So that is the probability of either getting a king or a club. One last example was the probability of getting a female or Florida out of the committee members listed in the table. Okay, so first of all, probability of someone being female in this table. There are, let's see here, 8 plus 6 is 14, 21. There's 21 females listed here out of a total of 31 committee members. Okay, and then from Florida, again, or means add. There are 12 committee members that are from Florida. Okay, so let me just highlight this. That's everyone that's female. This is everyone from Florida. So we've got 12 of those out of the 31 committee members. But these females from Florida have been counted twice. So I have to come back and subtract those. So I get 8 over 31. And that's going to give me this 25 over 31. Okay, so that's the probability that if I randomly picked a committee member, they're either going to be 25 out of 31 of them will either be from Florida or they are a female. Okay, so please go check out the assignment on Canvas and let me know if you have any questions. Have a great day.